This is a shout out to Mr. Spellmeyer because you don't think golf is a real sport. Here's our problem. Jamie is practicing golf and needs to hit a golf ball over a 40-meter wide water hazard into a hole 90 meters downstream. However, she didn't eat anything today and will pass out if she uses up too much energy. If it takes 1.5 times as much energy to hit the ball over the water as it does over land, how far downstream should she hit the ball in order to expend the minimum amount of energy?
So our first step is to draw a diagram representation of what our problem is stating. So we have Jamie over here at this end, right here, and she is 90 meters away from the hole, which is this distance away, this length, and the hole is on this side. So what's going to happen is she's going to have to hit somewhere over here and then hit to the hole that way to conserve her energy. We can label the portion up here x, and this would be 90 minus x. We also know that this is 40 meters over here. So our next step would be to set up an equation relating her distance and her energy conservation. So we can say that E of x equals 1.5 times the square root of 1,600 plus x squared. Okay, so we found this length using the Pythagorean theorem. So we end up with the square root of 1,600 plus x squared. Going back to this, k is actually our energy constant in the problem. We can continue the equation by adding k times 90 minus x. We do this part right here is this length. Now we're going to do this length because she has to finish the hole, and so once she's over on this side, she has 90 minus x to go, and she uses k amount of energy. So our next step is to find the derivative with respect to x. To take the derivative, e prime of x equals 1.5 kx divided by the square root of 1,600 plus x squared. And then we subtract k from that. So that's all taking the derivative of that.
So in our problem, we're trying to minimize the amount of energy Jamie spends on her shot. So to do this, we need to find a minimum value of our derivative. We do this by setting our derivative equal to 0. So when our derivative is equal to 0, we have 1.5kx divided by 1,600 plus x squared minus k. This is going to equal 1.5x minus 1 divided by the square root of 1,600 plus x squared. From there, we just solve for x. We get the square root of 1,600 plus x squared equals 1.5x. Then we get, and if we square both sides, we get 1,600 plus x squared equals 2.25x squared. From there, we get x as 16 rad 5. This is approximately around 35.777 meters.
So now that we have our 35.777 meters, this is our answer to our problem because we are looking for our x value, how far we have to hit downstream in order to get the least amount of energy used.